Hello everyone. Today we are going to discuss about mathematical analysis of algorithms. So, to discuss the mathematical analysis, we must know about the performance analysis. What do you mean by performance analysis? In the general thing, performance analysis or the performance of any program or algorithm means we'll be just having two things. First one is the time efficiency and second one is the space efficiency. So here time efficiency and space efficiency will be called as the performance analysis by using the time and the space, how much space the algorithm is taking. By these two things, we'll just analyze the performance of the algorithm. So here, first time efficiency means how much time the algorithm is taking in order to complete the execution. Means, for example, if I'm just going with any of the sorting algorithm or any of the searching algorithms, what is the time the algorithm is taking in order to complete its execution? Means how many input it is taking, for that input how long the time it is taking. For example, for 100 inputs it is taking 5 minutes, for 200 inputs it is taking 7 minutes. Like that, it will be just taking different time for different inputs, number of inputs. So that is called as time efficiency, how long the algorithm is taking to complete its execution. And at the same time, space efficiency means here how much space the algorithm is taking in order to store the input or in order to store the components what we are giving for the algorithm. Here mainly for the mathematical analysis, we are just going with the time efficiency, how long the algorithm is taking to complete its execution. So that is time efficiency. So with the calculation of time efficiency is called as your mathematical analysis. In order to go for mathematical analysis, first we must know about the concept of basic operation. What do you mean by basic operation? Basic operation is nothing but each and every algorithm will be having its basic operation. For example, if I just take addition of two numbers, so I'll just go with the parameters a is equals to 3 and b is equals to 2. Here, how you will calculate the addition? C is equals to a plus b. Yes, so to a 3 and then b will take c is equals to 5, you will find out. So this is the basic operation what we are performing in order to find out the addition of two numbers. So the instruction which is executing a number of times, okay, or repeatedly if we are considering any of the instructions, then that is called as the basic operation of the algorithm. If sorting or searching algorithms will be just having the while loop. So what are the statements will come under this, inside this while loop will be considered as the basic operation. Here this is non-recursive algorithm. Non-recursive algorithm means there will be no repetition or the recursion. Just you will give the value for a and b, then I'll be calculating. Only once we'll be using. In non-recursive algorithms, always the basic operation will be equal to 1. But in recursive algorithms, repeatedly it will be just going to the same instruction. Yes, so while loop, if I have some statement over here, until the while condition is false, it will be just going inside this loop. That is called as recursive algorithms. Here it will be n number of times. It depends on the size of the input or the size of the input what we are just giving. That depends on the value of n. If n is equals to 4 you are giving, then 4 times it will iterate. N is equals to 100, you give 100 times it will iterate. So this is how for the mathematical analysis for recursive algorithms and non-recursive algorithms will be different. The formula, everything will be same, but the way we do is bit different. So we must understand the basic operation, how many times the basic operation is executing in order to calculate the mathematical analysis. Once it is done, at the end we have to just say what is the time taken by the algorithm. Is it not? There also we'll be having three cases that we call as a asymptotic notations. That is best case, worst case and average case. Best case, worst case and average case. With respect to this one, we'll just analyze the algorithm, whether it is in the best case, whether it is in the worst case, or whether it is in the average case. I'll just tell you how to just do that one. For example, I'll take a searching algorithm. I have the numbers 10, 20, 30 and 40, 50. I'll just take a key element as 50 first. Okay, if I take key element as 50, then here you have to just, from where you have to start searching the algorithm or the number from the beginning. 50 and 10 is equal, no. 20 I'll compare, no. 30, 40, 50, yes, 50 is present over here. So where is 50? 50 is present at the last position. Yes, 50 is present at the last position. So here from the beginning I started and until last I have just searched for this element. So this is called as worst case. If the element, the element which we are searching is present at the end of the array, is called as worst case. And then if I come to best case, it is not only for 50, it is for 40 also, 40 or 50. For worst case, one more thing is, if key element is 60, element not found, in this case also I have to traverse through the end of the array. So here until the end we have to traverse, but still the element not found. Even this is also worst case. If the element is not at all present or element is present at the end, then that is called as worst case. Best case is if the element which we are searching is at the beginning of the array, that is either 10 or 20. In one iteration or two iterations only, we will just find out this one. So we call this as a best case efficiency. Okay. Average cases, it is neither in the first nor in the last. It will be in the middle. That is called as average case efficiency. So here asymptotic notations I have told. We'll use the notations omega. For best case, we'll use omega. Then for worst case, big O. And for average case, we'll just write theta. For example, if the time taken by the algorithm is log n, so if it comes under average case, then I'll just write it as theta of log n. So this is how I'll just write the mathematical analysis for any of the algorithm. So before calculating the mathematical analysis, we must know the basic operation, and then we must know whether the algorithm is in best case, worst case or average case. This is just an example I have given, that this best case, worst case and average case depends on the problem statement. For example, if we take sorting algorithms, in sorting algorithms we'll never come up with the best case or the worst case, because here all the elements has to be just checked. For example, I have 5, 1, 4, 2. I have to sort this. Yes, if I have to sort this, then I have to traverse through each and every element of the array each and every time. Is it not? So here this is not like first position or the last position. Here I have to traverse through all the elements, so I cannot say whether it is best case or worst case. So in this case, I'll just go with the average case efficiency. Okay, I'll just tell you how to find out this best case, worst case and average case when I just take the particular algorithms. So these are the main things we need to consider for mathematical analysis. First, we'll go with the mathematical analysis of non-recursive algorithm. Yes, so here first you need to find out the input operation. What is the input you are just giving for that non-recursive algorithm? First step is to find out the input. Next step is to find out the basic operation, how many times the basic operation is executing. And then third one, you have to just find the summation of it, sigma. We'll just use sigma for that one. So summation of that we have to just find out. Okay, so this is how we'll be going with the mathematical analysis of algorithms. Today in this, I'll just take one example for a non-recursive algorithm. Yes, to find out the maximum value. among the elements. So I'll just write the algorithm for that. So this is the algorithm we have for finding out the maximum value in the given array. If I take one array 10, 25, 40 and 5. If I am taking this array, this will be a of 0, a of 1, a of 2 and a of 3. Among these 4 elements, I have to find out which is the maximum element. Yes. So here initially see max value is equals to a of 0, which is there in a of 0, 10. So initially max value will be equal to 10. For I is equals to 1 to n minus 1 is nothing but I is equals to 1, I less than equal to n minus 1 and then I plus plus. Yes. So the proper for loop, but in algorithm we'll write it like this. First I'll just assign max value is equals to 10. Then initially I value is equals to 1. I'll just check I less than equal to n minus 1. 1 less than equal to n minus 1. N is what? N is equals to 4 here because I have taken 4 elements. N minus 1 means it is 4 minus 1, it is 3. 1 less than equal to 3, the condition is true. And then if the condition is true, then I'll come here if a of I greater than max value, that is a of I value is 1, a of 1 is greater than max value, is 35 greater than 10. Yes, condition is true. Now new max value will be what? A of I. So previously max value was 10. Now I have compared 35 is greater than 10. Condition is true. So 35 will become the max value. Once again increment the value of I. Now what? I will become 2. I is equals to 2 is 2 less than equal to 3. Condition is true. Then a of I greater than max value. What is I value? I is equals to 2. So I is equals to 2 means here a of 2. What is there in a of 2? 40. Is 40 greater than max value? Our new max value is 35. 40 greater than 35. Condition is true. And then max value is equals to what? 40. Next increment I value. I is equals to 3 is 3 less than equal to 3. Condition is true. Then a of I, that is a of 3. What is there in a of 3? 5. Is 5 greater than 40? No, condition is false. Condition is false means it will just return the max value. Okay. So here, sorry, it will just go back to the for loop. I is equals to 4. Max value will remain same, that is 40. It will go back to the for loop. I is equals to 4. Is 4 less than equal to 3? No, condition is false. So condition is false means then it will come out and it will go to return max value. What is there in max value? 40 is present at max value. So 40 will be written as the max value here. So this is how the algorithm is going to work. Now you have to find out the input. I am giving n as input over here. And you have to just find out the basic operation. Which is the basic operation here? Here, inside the loop, what is present if this one? Max value is equals to a of I. This is the basic operation we have. I have just always told you basic operation will be always equal to 1 for non-recursive algorithms. Because if this condition is true, then only it will execute, otherwise it will not execute. Only one time it is going to execute because max value will be equal to 40. Is it not? Means in order to just check, it will just iterate, but it is not iterating a number of times. So the basic operation will be equal to 1. So first I have to just write the, now I just know what is my basic operation and what is the input we are just taking over here. Now I have to just find out what the mathematical analysis for this one. So how to write the mathematical analysis? I'll just type C of n. This is the function for mathematical analysis. Okay. Summation, I have told you, you have to just go with the summation. Summation If you take summation, then you have to just take the upper bound and the lower bound. Here, if we have for loop, which is the upper bound, upper bound is n minus 1. Until n minus 1 I have to do. What is the lower bound, which is the lowest number you are taking? I is equals to 1. That is the initial number of I. I is equals to 1 to n minus 1. And you have to just write the basic operation. Basic operation, I have told you, in this non-recursive algorithms, it is always equal to 1. Okay. So here, how to find out the mathematical analysis is, we have a formula: upper bound minus lower bound plus basic operation. Here, what is the upper bound? Here, upper bound is n minus 1 minus lower bound is 1. Basic operation is also 1. 1 and 1 will get cancelled. So, C of n is equals to n minus 1 I will get. Here, this n is called as order of growth and 1 is constant. So, we are not, while writing the mathematical analysis, we will take only the order of growth, will not consider the constant. So here I will ignore this 1 as a constant and I will take only n. And here, in which case it will come? Best case, worst case or average case? Obviously it is average case, as I have just told you. So here, in order to find out the maximum value, what I have to do? I have to traverse through all the elements. I have to check each and every element here. So it is not like in the beginning of the array and we are now finding it at the ending of the array. But wherever it may be, I have to traverse through all the elements. So this will comes under average case. Average case means you have to write theta. So I'll just write C of n belongs to theta of n. This n I have taken from here, what we have calculated. So this is the mathematical analysis for the algorithm to find out the maximum value among the array. So if you don't have for loop, then we have a different method that we'll see in the next video. Okay, thank you.